Hello makers. Okay, in the last video I finished off at the point of power up of the Fred's head. Now there are a couple of reasons why I did that. The first one being that the video was getting to be very long. It was 29 minutes after editing. The second one was I ran into a snag. On power up, the two lights on the power supplies came on, the lights on the Raspberry Pi itself came on, but that was the only sign on the light on the PCA 9685 came on. And that was the only sign of life that I had out of the head. Nothing else worked. I couldn't connect to it with VNC no matter what I tried. I couldn't even find it on the network. So after much investigation I ended up pulling the micro SD card out and firing it up in another Raspberry Pi and discovered that the problem was it was going into kernel panic during boot. It was unable to mount the main partition. It's a corrupted SD card. So I formatted the micro SD card and reinstalled the system. 12 hours later it did the same thing. So I suspect this micro SD card, which is a Eagle Tech 32 gig, is failing and corrupting without warning. So I've got a verbatim 32 gig micro SD card that I've had floating around. So I formatted that and set it up. Now we have a working system. And when I tested it 12, 24 and 48 hours later, it still boots up quite happily. So in the background we've got the rework soldering station that I've been using. This blue cable, by the way, is network because I haven't configured the Wi-Fi on the Raspberry Pi yet. It's something I've still got to do. But this soldering station does have a 0 to 15 volt 2 amp power supply, and this is what I've been using to power Fred's head while I've been testing. So I'll turn it on and you can see I'm outputting 7.2 volts. You can see the current's changing. As it boots up it'll actually increase its current until it reaches full operating. Now I can adjust, when this is stable, I can adjust the voltage and you'll actually see the current changes with the voltage. As I increase the voltage, the current will actually drop. So that's pretty much booted up now. I can bring up VNC in a minute and show you. But as I increase the voltage here, you'll see the current drops. And there's advantages to doing that. So as long as I stay above 4 volts, the system will continue to run quite happily. Now I am planning on running this initially on 6 volt and then on 12 volt with the battery. I do have some larger switch mode power supplies coming to put in the arms. I did try small ones once and I ended up breaking an arm as a result. So the bigger ones should handle the load of the bigger servos. And that'll allow me to bring the whole system up to 12 volt while still providing 6 volt to the servos and the arms. So let's get going. If I turn this around you can see the light on the PCA. If I tip the whole lot over you can see the light on the Raspberry Pi. There's another light on the switch mode power supply down the bottom for the servos. And if I can get the right angle through the ear, you can see the light on the switch mode power supply for the Raspberry Pi itself. I've tidied up all the wires with a bit of spiral wrap. I can separate the servo supply, which is the wires, or these two wires, the brown and blue, and the Raspberry Pi wires, which is the red wires, and put them on different power supplies. I have, while experimenting with it to make sure it did work prior to this video, discovered that if I put too much load, particularly on this bottom servo down here, which has the biggest load, it will overload the power supply. The power supply will reset and it will literally shut down the Raspberry Pi, and then everything will boot back up. And if it happens to be in a movement at the time, it's quite probable it will roll, which is what it did right over my keyboard. So I'm going to change to using a GoPro to look at the face. I'll try and sync it up with a capture of VNC. Okay, so I've got my robot lab running now. No, I haven't. I've got the Raspberry Pi running. Let me start my robot lab. Java -jar my robot lab.jar. Now, being Manticore, this starts the GUI, known as Swing GUI. And for this demonstration and testing, we're just going to start the runtime. Scroll down to find Raspberry Pi and start it. I'll just call it RasPi. Now, the Raspberry Pi has no settings on it, so in Swing GUI there are no settings for it. The next one we need is the servo controller. Now, the Raspberry Pi has an I2C interface on it. The Adafruit 16-channel servo requires an I2C interface, so we'll start it. We'll call it head because this is located in the head. And when we go into that, because I have no other devices connected, no Arduinos or anything, it only lists the Raspberry Pi as being available. On the Raspberry Pi, make sure you select bus 1. On the Arduinos, make sure it's bus 0. Now, the address for the I2C drive, or the Adafruit 16-channel driver, is by default 40 unless you change the jumpers. In the previous build of Fred, it was set at 40, so we'll leave it as that, and then we can attach it. So you can see in the background, every time we do something here, it actually shows up in the status in the CLI, command line interface. So the next thing we want to do is play with the servos. So here's a servo. That was a mistake. Servo's not listed under servos. But it is listed under control. So let's start a servo. I'm just going to call it servo 1 for now. We can name it something different when we get round to writing scripts. So if we go to servo 1, you can see here we need to select the controller, which is head. I've only got the one servo controller. Now, all of our servos are connected starting at pin 15. So we'll go to pin 15 and attach. Now, as soon as we move the servo, it'll actually update. And you can see the right eye on that left side there is now moving. Now it looks like as it goes through the centre position, where the arm is facing straight down, it's causing the whole mechanism to rock. So I'm going to have to pack up the back of the eye mechanism to prevent that from happening. but that's not a major drama, we can do that. More importantly, we can now adjust where our centre position is, which is pretty close to there. That's 180 and that's 0 there. Oops. So that's cool. Now if I detach that and go to pin 14 and reattach, we can now move the eye up and down. So let's just go through each of the different points and attach. So that's the left and right on our left eye. The up and down on our left eye is on pin 12. Our upper eyelids are on pin 11. Pin 10 has the lower eyelids. Pin 9 should be the jaw. Pin 8 should be the rotation of the head. This is the one where I broke it last time, was pin 7 is actually the bottom servo here. So I'm going to leave that one alone at the moment and not use pin 7. So now that we've got that working, I think my light's changing. Let's go back into programming. Okay, so from Python I've actually created a script and I'm going to open it now. So let's go through this script and have a look at how it works. Now this is just a small sample script, it's not fully implemented, but I have put in all of the basics and I've also set up a blink routine on it. So the first thing we need to do is start the Raspberry Pi service, which is called RasPi. The next thing we do is start the Adafruit 16 channel servo driver service, and we attach that to the Raspberry Pi bus 1, specifying an I2C bus address 0x40 hex, which is the default for those modules. Now this is where I'm going to do something a little bit different. I'm going to start the clock service. There is help on this on the My Robot Lab documentation, so you can actually see how this works, but we're going to start the clock service. Now we're going to start creating servos. So this is a servo service for the right eye left right movement. The right eye left right movement gets attached to the head on port 15. The right eye up down movement we create as a servo, and we attach that one to pin 14 on the head. We continue this with the left eye left-right movement on pin 13, the left eye up-down movement on pin 12, the upper eyelid on pin 11, the lower eyelid on pin 10, and the jaw we're going to attach on pin 9. Okay, so the next section of codes is all about setting the limits and the mappings. So by default they are set at 0 and 180, which is the full range of motion of a servo, or most standard servos, and the mapping is also set the same way. We can actually set in My Robot Lab a rest position, so when you issue the rest command it will make the servo go to that position and then it'll turn off the servo. We can invert a servo to make it go the opposite direction, so where it would normally be, say 0 is all the way to the left and 180 is all the way to the right, we can actually reverse that, so that 0 is all the way to the right and 180 is all the way to the left. Velocity is how fast it moves. Now, when you're running servos from the Arduino attached to My Robot Lab, it offloads the movement control, the velocity, to the Arduino. In the case of the Adafruit, it has to do it itself. So it actually sends a series of positional commands to the Adafruit servo driver for that port. So it moves things very smoothly. It does work, but it does add a lot more traffic to the I2C bus during movement. If you set it to -1, it turns off velocity, and so when you set a new position it will go there as fast as it can. So we do this for each of our servos. When we get to the eyelids, however, upper and lower, I've done a little bit more experimenting and I did have to modify it a little bit. Add a couple of pins in because the wires weren't working very well, but with the pins it does. So the wires connect to the pins that are sticking up. The pins I used are 2mm screws, metal thread screws that I had on hand. I think they're about 15mm long. So what I've done is the upper eyelid, I've checked the range and I found 60 to 180 is a good range for where 0 is, or 60 is all the way closed, no, all the way open, sorry, and 180 is all the way closed. And I've also set the mapping up so 180 is mapped to the range that we've actually got. I've set rest at 72, which is not all the way open, but it is open. Inverted is not being operated. Set velocity -1 means I've turned off velocity control, so it goes as fast as it can. Auto disable is true. There is a bit of an issue with the auto disable in the case of the eyelids or any of the servos. If auto disable has disabled the servo, you must turn it back, re-enable it before you start moving. So I found out the hard way. And rest will make it go to position 30 and disable. We do the same. We've got 72 here. We do something similar for the lower eyelid. So this was all done by trial and error to work out the distances. We also set up our jaw. I haven't actually configured the jaw. Closed is around about 90, and from memory 0 is open. Now I've defined a function or a routine which I've called blink, and because it's going to be called by the clock service, I need to pass time data even though I'm not using it, otherwise it crashes. First thing I do is I enable the servos for both the upper and the lower eyelid when this function is called. Then I move the eyelid to 150 and upper and lower to 150. I wait for 0.8 of a second and then I move back to 30 and 30. That effectively closes the eyes and then opens the eyes back up again. Now I'm going to, down here, I add a listener to the clock, call it pulse, and it will call the blink function. Clock set interval is set for 10 seconds or 10,000 milliseconds, and then I start the clock. So it's a very simple script that doesn't cover everything. There's no talking, there's no program AB, there's nothing in it really. The eyes don't really move. The only thing it does is make it blink. So up the top here, this right hand most icon executes the program. And if all goes well, it should start blinking every 10 seconds. Which it does not appear to be doing. Alright, now that I've moved it, it is. So now you can see it's blinking. There's still a few little minor bugs to work out with how this is working. There's something I'm missing in the startup. When I do find that code, I will add it in there. In the meantime, the code will be up in my Dropbox. I'll put a link to it in the description of this video. So that'll do us for this video, I think. There's a lot more coding needs to go into this. It will take me time to work out the coding and debug it. I think I need to also add in a streamer service to the Raspberry Pi so that I can actually access the content of the camera, so we can see what the camera's looking at. But within this I can now open or move the various eyes. That one's got a speed set on it of 60. So one of the things I think I'll need to do is create a routine that will let me actually set both eyes at the same time, and I'll need to tune the mappings for those, for both up, down and left, right on both eyes. And then we can start to pass in tracking data if we need to point the eyes, and they'll move together. Yeah, so to see when the next video on Fred's Head comes out, don't forget to click on subscribe, click on the like button if you like this video or this series of videos. Don't forget to ring the bell notification. The next video I put out will probably be the beginning of the Walking Robot series. There may be videos in the mix between this one and the Walking Robots. I really do want to get a start on the Walking Robots. I also still have to work out the Seed Studio AI board. So I need to figure that one out and get that in there. This is supposed to be able to do video recognition, like object recognition and facial recognition. So that's one I've still got to work on, and I want to get that in there as well, and hopefully tied into my robot lab in some fashion. I may have to do it through the serial. Maybe. Alright, so I will see you in the next video. Don't forget to have fun making robots.